Today we're going to do some review on compound events, and we're going to do it out of the probability and statistics practice packet, which looks like this. So please make sure that you're in the correct packet and not in the regular notes packet. We're going to be on pages 14 and 15. In the first set of examples, we're told that there are 12 boys and 18 girls in the class. If we pick students at random to go to the next Super Bowl, and in number 1 and number 2, the student can be picked multiple times, we're going to find the following probabilities. Okay, so if a student can be picked multiple times, this means with replacement. I'm going to pick a student to win the tickets the first time, and then they get to be in the drawing again for the second set of tickets. So we're going to have the same number of students each time that we try to pick winners for the Super Bowl here. So in question number 1, I want to know what's the probability of getting a boy to win the first time and a girl to win the tickets the second time. So let's find the simple probabilities first. The probability that a boy is going to win, well, we were told up here that there are 12 boys, so I'm going to have 12 out of, okay, and we have to figure out how many students are in the class. There's 12 plus 18 girls. That's a total of 30 students. So the probability that the boy wins is going to be 12 out of 30. Okay. Now that student goes back in the drawing for the second set of pictures, or tickets rather. And so we want to get a girl to win this time. Okay. So for the second set of tickets, if a girl is going to win, that's going to be a probability of 18 out of 30. Okay, now to get the compound probability, we would multiply those together. That's going to give us an answer of 216 out of 900. Okay, but I'm going to simplify this. I'm going to go back here and I'm going to see, well, 12 and 30 have a common factor of 6. So 6 goes into 12 twice and into 30 5 times. And 18 and 30 also have a common factor of 6. 6 goes into 18 3 times and into 30 5 times. And now when I simplify this, 2 times 3 is 6, and 5 times 5 is 25. So our compound probability is going to be 6 out of 25. If I wanted a girl to win both sets of tickets, okay, well, the first time for a girl to win, the probability is 18 out of 30. And remember, that girl has a chance to win again, so the probability the second time is also 18 out of 30. We multiply those together and we would get 324 out of 900. And again, I want this in simplest form. 18/30ths, I just simplified up here. Both of these can become 3/5. 3/5. So now 3 times 3 is 9, and 5 times 5 is 25, making our compound probability 9 out of 25. With questions 3 and question 4, the student can only win one ticket. So this is going to be without replacement. So the person that wins the first time can't win a second time. So we want the probability that a boy wins and then a girl wins the ticket. So let's start with the boy. We said before that the probability would be 12 out of 30. But now that person can't win again. So for a girl to win the second time, well, there's 18 girls in the class, but it's only going to be out of 29 students this time because the first person can't win the tickets twice. So I'm going to multiply these two probabilities together, and that's going to give me 216 out of 870. Okay, and again, I'm going to put that in simplest form. 18 and 30 have a common factor of 6. So I can go 6 into 18 3 times, 6 into 30 5 times. And when I multiply now, all right, 12 times 3 is 36. 5 times 29 is 145. And that is going to be our compound probability. Okay, if I want 3 girls in a row to win tickets to the Super Bowl, okay, so for the first girl to win, it's an 18 out of 30 probability. There's 18 girls out of 30 students in the class. Okay, now the girl that wins the first time can't win the second time, so now there's only going to be 17 girls out of 29 total students in the class. Okay, and then the person that wins the tickets here can't win them again. So if it was a girl for the third time, now there's only going to be 16 girls out of 28 students in the class. And we'll multiply all 3 of these together in order to get our compound probability. And that's going to give us some big numbers here. It's going to be 4,896 out of 24,360. Okay, but we can simplify that. 18 and 30 have a common factor of 6. That's going to become 3/5. Okay, 16 and 28 have a common factor of 4. 4 goes into 16 4 times and into 28 7 times. And now when I multiply 3 by 17 by 4, that gives me 204 over 5 times 29 times 7. That's going to give me 1015. And that is our compound probability in simplest form. In the next set of problems, we're told that a bag contains 4 green, 3 red, 1 white, and 2 blue marbles. 2 marbles are drawn at random with replacement. So we're going to find the following probabilities. Okay, so first we want to get a green marble and then a red marble. Okay, so we're going to first count up how many marbles there are. 4 and 3 is 7, and 1 is 8, and 2 makes 10. So to get a green marble, the probability is going to be 4 out of 10. Okay, now this is with replacement. These are independent events. We're going to have the same number of marbles in the bag all the time. So now I want to get a red marble the second time. So there are 3 red out of the 10 that are still in the bag. Again, we put that first marble back. And now we can multiply, and we would get 12 out of 100. Okay, if we wanted to simplify this, okay, 4 and 10 have a common factor of 2. So that could be 2/5. Okay, and then this 2 and this 10 have a common factor of 2. So that would become a 1, and that would become a 5. And so now 1 times 3 equals 3. 5 times 5 is 25, and that's our compound probability in simplest form. If I wanted a blue marble and then another blue marble, okay, well, the probability of getting a blue marble the first time is 2 out of 10. And the probability of getting a blue marble the second time is also 2 out of 10 because we put the first blue marble back in the bag. That's going to give us a probability of 4 out of 100. Okay, but both of these 2/10 you can simplify early down to 1/5. And that would make our simplified compound probability 1 over 25. If I wanted a red marble followed by a white marble, to get a red marble, it's going to be a 3 out of 10 probability. Okay, we put that marble back in the bag, so to get the white marble now, it's 1 out of 10. And that's going to give us a compound probability of 3 out of 100, which is already in simplest form. If I wanted a green marble followed by a white marble, to get a green marble, that's a probability of 4 out of 10. Okay, and to get the white marble, that's going to be a probability of 1 out of 10. And that's going to make our compound probability 4 out of 100. And again, we can simplify. All right, the 4 and the 10 have a common factor of 2. That would become 2/5. This 2 and this 10 have a common factor of 2. That would become a 1, and that would become a 5, making our final probability 1 out of 25. In the next set, we're told that Edison is eating M&Ms. In the package, there are 12 pieces of candy left. 6 are green, 2 are red, 3 are blue, and 1 is yellow. Find the following probabilities of Edison eating certain M&Ms. So in the first example, we're going to have a green M&M followed by a yellow M&M. Okay, so looking for a green M&M the first time, that's going to be 6 out of the 12 that are left. 6 out of 12. Okay, and then we want to get a yellow candy the second time. Okay, well, they tell us there's 1 yellow candy. Okay, but remember, Edison picked a green candy out and he ate it. He didn't put it back in the bag. So these are dependent events. There's no longer 12 in the bag. Now there's only going to be 11 pieces of candy. Once you pick one, you eat it. Okay, so now we're going to multiply these two probabilities together. That's going to give me 6 out of 132. Okay, but I can simplify that. 6/12 is the same as 1/2. Okay, so 1 times 1 is 1. 2 times 11 is 22. And there's your probability in simplest form. If I wanted a red candy followed by a blue candy, okay, red candy first, well, that's 2 red out of the 12 pieces. So 2 out of 12 is the probability to get a red candy. And remember, we're going to eat that red candy. So now for the blue M&M, it's only out of 11 pieces left, and 3 of them are blue. So we're going to do 2/12 times 3/11, which is going to give me 6 out of 132. Okay, but again, I can simplify. All right, 2 and 12 have a common factor of 2 to make that 1/6. 3 and 6 have a common factor of 3 to make the 3 a 1 and the 6 a 2. So this is going to simplify down to 1 over 22 in simplest form. Okay, in the next example, we're going to get 3 M&Ms. We want a green, another green, and then a yellow. Okay, so to get a green M&M the first time, we said that was a 6 out of 12 probability. We eat that green M&M, so now there's only 5 out of 11 pieces left for the second green M&M. Okay, and now for the yellow M&M, we were told that there's 1 yellow, but there's only 10 M&Ms left in the package after we eat the first 2 pieces. And so we're going to multiply these numbers together. And that's going to give me a compound probability of 30 out of 1,320. Okay, again, I'm going to simplify. 6/12 is the same as 1/2. 5 and 10 have a common factor of 5 to make the 5 a 1 and the 10 a 2. Okay, so this is going to make my compound probability 1 over 2 times 2 is 4 times 11 is 44. 1 out of 44. Okay, and then I want a blue, a yellow, and then another blue M&M. To get blue the first time, that's going to be a 3 out of 12 probability. To get the yellow M&M, that's 1 out of 11 since we ate 1 M&M already. And now to get another blue M&M, well, remember, we had 1 already, so there's not 3 in the package. Now there's only 2 out of 10 that are left. So when we multiply, that's going to give us a probability of 6 out of 1,320. And let's see if we can simplify here. Okay, 3 and 12 have a common factor of 3. That's 1/4. 2 and 10 have a common factor of 2. That's 1/5. Okay, so for my numerator, 1 times 1 times 1 is 1. 4 times 5 is 20. 20 times 11 is 220. So there's your probability in simplest form.